Homemade solar water heating black box. Introduction. A solar heater is a heater that is powered by the sun and uses its raw energy to heat objects. The solar heater that we built is a passive solar heater. That is because it uses the energy straight from the sun to heat the half-gallon of water, not machines harnessing it. Solar heating can be done in many different ways. One way would to use passive heating. That is when you use no machine devices, while the active solar heating are machines that harness the energy to power other things. Solar heating is related to this project because we use the sun to heat our water. The one method of solar heating that we used was passive solar heating.
Purpose and objective. We chose our design because black absorbs the sunlight, styrofoam soaks in all of the heat, the glue and tape we use is to hold it all together, the tinfoil holds the heat, the plexiglass holds the heat in the box, the cardboard is what we use to hold the tinfoil in the box. We didn't have many problems during the making of the project.
Hypothesis. We thought that our temperature would rise 20 degrees Fahrenheit, negative 6.667 degrees Celsius, above the control temperature of 7 degrees Celsius.
Materials. Styrofoam glue, glue gun, plexiglass, tape, tinfoil, plastic bowl, black paint, and cardboard.
Procedures for assembly. We got foam boards that were 30 centimeters by 30 centimeters and painted one side of each black. We took two sides of the boxes and cut a 4 by 4 centimeter square out of the lower center. Then we took two squares of plexiglass and glued them to the squares already cut out. Then we glued it together with the black side facing out to make a box using Elmer's glue and duct tape. Then we took a piece of cardboard about 30 centimeters and cut it into 4 triangles. Then we covered those triangles in aluminum foil and taped them to the edge of the box facing a 45-degree angle pointing in. Then we covered the whole inside of the box in tinfoil. We took plastic bowl and placed it at the bottom of the box. Then we took a sheet of plexiglass 30 centimeters by 30 centimeters and taped it down on the top on one side so it would be accessible to open.
Data. The control data was 7 degrees Celsius, which is 44.6 degrees Fahrenheit. We got 17 degrees Celsius, which is 62.6 degrees Fahrenheit.
Conclusion. Allow sunlight in but trap heat in. We had one plate of plexiglass on top and small pieces on the sides. Increase the surface area of the water so it will heat quick. Our bowl was large in circumference, making a smaller level. Water should be next to a conductor. Metal is good. We had aluminum foil surrounding the entire inside of the box. The area containing the water should be black. The outer part of our box was painted black to help attract the sun causing heat. Insulate outer area projects to prevent heat transfer. We didn't have any insulation on our project. We could have had heat loss from the ground. Use reflection or mirrors to concentrate light and heat. We didn't have mirrors, but we did have reflection from the sun hitting the aluminum foil. Angle objects 45 degrees to the southwest. We didn't have any angles which could have helped us catch more sun as possible.